Okay, in 4.8b, we are going to rationalize the denominator. We're going to divide complex numbers, and we're going to rewrite in a plus bi form. So, over to the left, we're going to do an example as we write out the steps. So if we have negative 1 minus 6i over negative 8 plus 2i. Our first step is going to be to multiply by the conjugate of denominator over the conjugate of denominator again. So when we talk about the conjugate, that just means to change the middle sign. So if we do step number 1, to multiply by the conjugate of the denominator over the conjugate of the denominator. So if we have negative 8 plus 2y is the denominator, if the conjugate means to just change the middle sign, we're changing the middle sign right there. Right now it's a plus, so we're going to change it to a minus. So our conjugate would be negative 8 minus 2y. So that's step number 1. Sorry. Okay, so step number 2. We are going to FOIL or distribute. In our case, we are going to FOIL. So if we start with the top, we're going to take the first, so we have negative 1 times negative 8, which is positive 8. We have the outside, so we have negative 1 times negative 2i, which is just a positive 2i. We have negative 6i times negative 8, the inside pieces, would be a positive 48i. And we have the last piece, so negative 6i times negative 2i is a positive 12i squared. Now let's FOIL the bottom. So our first, negative 8 times negative 8, is a positive 64. We have the outside, so negative 8 times negative 2i is a positive 16i. The inside, so we have 2i times negative 8 is negative 16i. And we have the last, so we have 2i times negative 2i would be negative 4i squared. So the first thing you're going to look for, you can do a self-check. These should always add to 0. Alright, so we know that I squared is negative 1. So instead of having I squared, if that's negative 1, what's 12 times negative 1? So looking at this piece, 12 times negative 1, we're going to change that to negative 12. And looking at this piece with the I squared, we have I squared is negative 1, so negative 1 times negative 4 is positive 4. Alright, so step number 3. So if the answer is in the form a plus bi over c, you must split it up into a over c plus b over c I, and simplify. So let's see if we have it in that form. So first we have to simplify. So looking at the top, let's combine our like terms. So what's 8 minus 12? Well, that's negative 4. we have 2i plus 48i is 50i, and that's over. We have 64 plus 4, which is 68, and we already said that 16i minus 16i is 0. So now we can see that this is in the a plus bi over c form. So let's split it up. So we're going to take our a over our c, which is negative 4 over 68, plus our b over c times I. Our b is 50 over our c, which is 68, I. And now we're going to simplify. So negative 4 over 68 reduces down to negative 1 over 17. 50 over 68 reduces down to 25 over 34, I. So once it's in this form, you need to split it up, a over c plus b over c, I, and then simplify. Okay, so next, let's talk about factoring using complex conjugates. Alright, so the first one, we have sum of squares, which is a special case that we already talked about. So we have f squared plus l squared. So if this is the case, we're going to end up factoring, and it's going to look something like this. We have f plus li and f minus li. And if we were to check this by FOILing, you'd get your first f times f is f squared, your outside f minus or times negative li would be minus fli. Inside, so li times f would be a plus fli. And your last, you have li times a negative li will be a positive li squared. I'm sorry, l squared I. ll would be squared, I squared. Okay, so looking at this, we can see that negative fli plus fli is going to cancel. And we know that I squared is negative 1. Negative l squared times negative 1 is going to change that to a plus. So we have f squared plus l squared. And we get what we started with. So let's do a couple examples. So we have x squared plus 16. Now looking back, we know this is a sum of squares. So this is going to equal, we're going to have two sets of parentheses. One's going to be plus, one's going to be minus. So if we unsquare x squared, we're going to get x. So this term is x squared, and we know this term is 4 squared. Square root of 16 is 4. So up here, like this one, if we unsquare 16, we're left with 4, and we still have our I. If we unsquare our 16, we get 4, so we're left with 4i. Alright, next example. We have x squared plus 81. Well, we know this is x squared, and we know 81 is 9 squared. So if we factor this one out, we said this unsquared was x. We solve our plus and minus. And if we unsquare 81, we're going to get 9. So we're left with 9i and 9i. Alright, so we have 2x squared plus 32. Well, this one's a little bit different because, as you can see, we have a GCF, and the most we can pull out of both of these would be a 2. And our GCF goes out in front, so if we pull out a 2, we're left with x squared. And if we pull 32 divided by 2, is 16. Now we factor like we did up here. You keep your 2 out in front. We don't want to drop that. If we unsquare x, or x squared, we're left with x. And we have plus and minus. If we unsquare 16, we're left with 4. So 4i and 4i. Alright, let's do an example where we solve by factoring. So when we do this, we're going to solve using the zero product property. So this is where we set them equal to 0. So for example, we have 5x squared plus 20 equals 0. So looking at this, we have a GCF of 5. So we're going to pull a 5 out in front. 5x squared divided by 5, you're left with x squared. 20 divided by 5, you're left with 4, and that equals 0. So now we have to factor this piece. So we'll keep your 5 out in front. If we unsquare x squared, we're left with x. And if we unsquare 4, we're left with 2y. And that still equals 0. So, like before, when we solved by factoring, we set whatever has a variable with it equal to 0. So we're going to take this piece and set it equal to 0, and this piece and set it equal to 0. So we have x plus 2i equals 0, and x minus 2i equals 0. So we are going to subtract 2i from both sides to solve for x. So x equals negative 2i. And let's go ahead and solve this one. We have to add 2i to both sides. And x is also going to equal positive 2i. Alright, last thing we're going to do is solving quadratic equations with imaginary solutions, which is our I. So, first example, we have x squared plus 2x plus 3 equals 0. So if we remember, quadratic is your x equals the opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. So looking at this equation, our a is the number in front of the x squared, which is 1. Your b is your number in front of your x, which is 2. And your c is your constant, which is 3. So let's plug it into our equation. So we have x equals the opposite of b. Well, our b is positive 2, so the opposite would be negative 2, plus or minus the square root. B squared, which is 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 1. So we get x equals negative 2, plus or minus. So we have 4 minus 4 times 1 times 3 is 12. Well, 4 minus 12 is negative 8. And this is all over 2 times 1, which is 2. So we have the square root of a negative number. So off to the side, we know the square root of negative 8. We know that the negative on the inside is going to give us our I, our imaginary. In your 8, you get 2 times 2 times 2. So all we're doing is simplifying the radical now. So we know that our I is going to come outside. We have our pair. So your pair of 2's is going to come out as well. And since this is only 1, 2, that's going to stay in. So if we simplify this, x equals negative 2 plus or minus. These 2 come out, so we have 2i. And since this is the only piece that stays in, we have radical 2. That is all over 2. So like before, we have to break it up. So we have x equals, we have negative 2 over 2 plus or minus, and we're left with 2i radical 2 over 2. Well, we see that we can simplify. We can divide these 2 and these 2, all divided by 2. So if we simplify that, negative 2 divided by 2 is negative 1. Over 2 divided by 2 is 1. So we have negative 1. And we're going to have plus. We know we're also going to have negative 1 minus. Because plus or minus, so one's going to be plus, one's going to be minus. 2 divided by 2 is 1. So we're left with I radical 2. And then 2 divided by 2 is 1. So that's over 1, so we don't need to write that. So again, if we simplified this, 2 divided by 2 is 1. So you're left with I radical 2. And 2 divided by 2 is 1. So x equals negative 1 plus I radical 2, and x equals negative 1 minus I radical 2. So let's do one more example like that. So we have negative 3x squared plus x minus 3 equals 0. So looking at our equation, we have a, which is negative 3, our b is 1, and our c is negative 3. So let's plug it into the quadratic formula. So x equals the opposite of b. B is negative, or b is 1, so the opposite of b would be negative 1, plus or minus the square root. We have b squared. Well, b is 1. 1 squared is 1, minus 4 times our a, which is negative 3, times our c, which is also negative 3. And all of this is over 2 times our a, which is negative 3. So if we simplify this, we get x equals negative 1 plus or minus. If you take 1 minus 4 times negative 3 times negative 3, you get negative 35. And that is over 2 times negative 3, which is negative 6. So, if we simplify this radical, we know that the negative is going to give you an I, and we can't simplify 35 anymore. 5 and 7, so we don't have any pairs. So all we're going to do is take the negative out, so we have I radical 35, and that is over negative 6. So we can split this up. So we have x equals, you have your a over c, so your -1 over -6, plus or minus, and we have our b over c. So we have I radical 35 over -6. So x is going to equal, negative over a negative is a positive, 1/6, plus I radical 35 and we also have x equals 1/6 minus I radical 35 over 6.